We are going live. All right, I cannot see the stream starting. I'll.
Okay. I have things saying here live on custom live streaming service. But...
Yeah, but I don't see it on YouTube.
Oh, okay. Thanks for helping with the homework. That was good.
You're welcome.
It was quite a very interesting little task.
All right, if it's already visible on YouTube, we're going to start in a couple of minutes. I just need to sort out something and make sure that it's all going smoothly, and then I'll be with you.
Cool.
Tristan is saying that we're already live, but I cannot see on my tablet.
You ruined everything.
Hey guys, could you mute please? Oh, cool. Looks like it's working. And I have a confirmation that sound is going well. Then it's time to say welcome everyone to another session of the course on getting to know the standard library. My name is Alex Voronov, and this course is a part of C++ London University. We are a small charity organization which is helping people to learn C++. And today, we're going to continue talking about standard library containers and algorithms, and have a deeper dive on associative containers like standard map and unordered map and corresponding set and unordered set, and talking more about using them with the custom types. First, as usual, I'm going to advertise our Slack channel in CPP organized community on Slack, where people discuss related to C++. It's also like there is, for example, a channel #learn where people ask questions about communities and so on. And CPP London Uni also has its small, not so small community, and people discuss the lessons there, discuss the problems. Also, I post announcements there. Plus, basically, as you can see on YouTube, you can see the Zoom logo, and this means that we are streaming from Zoom. And if you want to ask your questions in person, you can find the details how to join on Zoom there. Please welcome. That's like more on the course. That's what we were. That's what we have been talking about so far, and we started with a little bit on unit testing, and then talking about basic containers. Then we had a first look on the standard library algorithms, and now we are into associative containers. We did the intro on the basic stuff about the containers, and today I want to focus more about using custom types as key types for the containers. In my experience, especially when I was learning, I had kind of a lot of troubles with them and a lot of cryptic compiler errors, and I decided it's worth explaining the details why it's so difficult, and also actually not so difficult, and how to overcome these obstacles and not be scared of your compiler error messages. We're gonna talk more about it, and I hope by the end of the lesson, people gonna be less scared of these very cryptic compiler errors. And that's the plan of the lesson. Basically, we start as usual with recap and updates, and then I'm gonna talk by the same structure about std map, as I'll give the introduction, and then we'll discuss a simple example, and then I discuss what if your type is more complex, and we'll have a little practice exercise, which also can work as a like you can use it as a break, and it's important to have a little stretch and just get a little air in your lungs, and then come back to the next part. Then we go basically the same way for the unordered map, and start with simple example, then dial it up with more complex type, and then finish it with another practice and probably another break. Then I will touch on multimaps and multi-sets, which is like another bit which we didn't touch the last time, and I decided it's just like worth mentioning. I also promised set algorithms, but I decided to move them to the next lesson, because it looks like there are going to be quite a lot of material to digest today. And also in the end, I've got quite cool home exercise for, basically it's going to be the last home exercise, and it's going to be a little bigger than all the previous ones, and I hope you like it. So we'll just need to have a bit more time to go through it this time. That's the plan for the lesson, and let's proceed. As part of recap, I remind every time, and also for everyone who is new to this lesson, that I decided that I'm gonna introduce unit test to the classes, and I picked a very simple unit testing framework, and I decided to make all the examples as unit tests. So they're going to be the code which describes what's what is the output of the code we've written, and you can compile it and run and see that it's actually working as expected. If you don't have any experience with the unit testing before, it's not a problem. Like the stuff we use is really basic, and I think really easy to understand. And also I'm gonna go briefly over the details and all the syntax on the first examples. And if you want to use it for yourself and compile it for yourself, you just go to the GitHub project, to the GitHub page of the project, and you need to grab a single include file and put it in your project folder. You can include it and start using straight away. If you need more details, there is a first session of this class where we talked how to find it, how to install it, and basically discuss more details about how the thing works and how to use it. Speaking of where to find the first session, I did a little bit of spring cleaning, and on the course page on GitHub, I've put a small README file which has links to the basically has titles of the classes and also links to the slides and to the YouTube stream. Unfortunately, we lost one on the string, but also it was the least interesting one, therefore not such a big loss. And therefore, if you missed something before, or even if you joined for the first time, feel free to follow the link and catch up on stuff you have missed before. And what did we do before? The last time, as I said, we were talking about associative containers. I introduced set, map, unordered set, and unordered map. And here is a small example which we were talking through, which illustrates some of the things which we covered. And on this example, we have the way you declare the map, which where you specify the key type and the value type or the mapped type. And we discussed how you access the elements and even add the elements with operator square brackets. Also, we discussed the pairs and what does dot first and dot second mean in terms of map elements. And that was the example how we counted the number of occurrences of the most frequent word in the sequence. If you want more details, you can, for example, skim through the slides of the previous lesson, which you can find on GitHub. And this is the last week home exercise. I was asking to figure out, is it possible to build a route from one airport to another? And I'll just, for those who haven't seen it, I'll give a few minutes to read through it, and then I'll show my solution. I've seen a few solutions meanwhile, and also a few correct solutions, which is good. But another interesting thing is just like complexity and efficiency of the solution, and that's an interesting topic to discuss here. All right, this is the way I did it. The idea that I want first I start with a map, which for each airport store the set of airports which are connected to this airport. Therefore, I can have a pretty quick lookup if one airport is directly connected to another. And then what I do is you can call it graph traversal. And also I store the set of airports which I have already visited. And the idea that I also keep I have two sets. One is those which I plan to explore and see if I have a chance to go through them. And also I keep track of those which I have already visited and had no luck. And then I put the first airport from the query to my set to visit. And until I run off airports to visit, I still have hope to get to the one I'd like to get to. And then I go through it. So that's how we go. We try one. If it's not, if it's the one we are looking for, we are successful. Otherwise, we move it from our to visit target to visited, and also try to visit all the connected airports. That's unless we visited it already, and that's how we go. In terms of complexity, it's going to be all of number of the airports times number of connections. You probably can do better, but I wasn't aiming for the ultimate efficiency and performance. Is just also like one of the metrics I was optimizing is being able to fit on the slide my solution and kind of have it readable, and also only using the stuff which we have discussed before. And here I'll provide an opportunity to ask questions if people want clarification.
Yeah, so I've tried with the Multimap to store the direct flights. In general, do you prefer Multimap or something like what you did like with a nested data structure, with a map, with another map of sets?
It depends, as usual. And here, what I think Multimap may work, but first, we haven't talked about them yet.
Yeah.
Second, it's just usually they're harder to follow and have more verbose interface, and it feels like just like mapping to a set would do. And you need to keep in mind efficiency and being able to like insert things and so on. And here it goes like it doesn't have extra requirements, but I think an Audit Multimap will give the same performance here.
Oh, yeah, another Multimap. Instead of another map with the value being another set in your case.
Yeah.
Because what I did is another map, and the value is just a string, but not a set. So I represented the data differently. But what was your thought process to arrive to this data structure? Was it your the first thing which sprang to your mind, or you attending with a few you played with a few structures before reaching that solution?
I won't say that it's like first thing which should be springing into everyone's mind, but for me it's kind of pattern which I used to solve similar problems, and I've also seen it in quite a few textbooks. And Multimap is not a typical data structure which you meet in other languages, as it can be in some additional collections and so on, and therefore it's a typical mindset where you use it like map to some set or a vector or something rather than using multimap. And that's what I decided to follow here. Plus, in terms of querying, basically, I usually like to hold the entire set, and when I have a bunch of iterators, it's more difficult to query. So I would say this solution is slightly more flexible, but it's not immediately an advantage because you might not need this flexibility.
Because the square brackets operator is not available anymore with the Multimap, since you can have several occurrences of the same keys.
Sorry, say it again, please.
Yeah, it's a bit to query. It's a bit more involved that compared to a normal map, the Multimap, because since the same keys can occur several times in the Multimap, then you need to use another method.
Yeah, but it's still pretty, like, we'll talk about equal range to the end of the lesson, and it's pretty straightforward how to turn this into just using equal range. Both in here and here, you can just use like the range of iterators, and it doesn't make any significant performance difference. at least like in terms of algorithmic complexity. In the real life, as I always say, you should measure.
Yeah, benchmark.
Any other questions?
Yeah, I think it's just one from me. I mean, I've been chatting about it, but originally, I guess the starting point for the problem is would you need multiple queries on the one data set? I mean, I like I said, I suggested you perhaps split it up into two, where you build the map with the unordered set inside it, and then you can just query on linear time if your program is constantly running.
Yeah.
So that's probably a fundamental question you perhaps ask at the start, is that do I need to repeatedly have to make the map?
This is a very good comment, and I was also thinking about it. Can I make it more efficient? And it's heavily dependent on use case. And another thing is, for example, which would affect it. Like first things first, really, I'll make a pause and just say this exercise is unlikely to be practical in a real world. And I had a balance between practical application and just how easy it is to express and to validate the problem, because in the end, here we are just practicing rather than solving the real world problems. But on the other hand, you are asking very real world question and making a good point. Usually you can build your data structure once and query it multiple times and do more efficient queries. And in this case, it's also going to dependent, as I said, for example, this one is O of number of airports times number of connections. And if I have small number of connections, therefore it doesn't hurt in general. If I have huge number of connections, I could see much more efficient data structure for this. If I have like big number of airports and also like really dense connections, therefore like a different structure will be important. And I agree with you that that's like a significant distinction, and solutions which kind of consider that that these two pieces could be split together are appreciated and welcome, and this is a good consideration.
In your solution, so you've got this set for the airports you have already been to, but could you update also in the another map? Could you update the another set to say, okay, I can't go back to that airport because it's already visited? Let's say Rix and Fra. Let's say this connection has already been done, so I'm going to update the set corresponding to RIX. Is it something you could have done or not?
I'm not sure I'm getting the question.
You know that you got this. You take. You are noting the airport you have already visited, so that you don't do like the return flights or something. You don't go. But you create a second set called visited.
Yeah.
Yeah,
it's
but
probably like for clarification. First, 5 lines are, as John pointed out, building the data structure which enables me to look it up. And this bit, starting from the visited set, is about to actually make a query. And therefore, kind of the first bit could be reused if it was like a class or something. And the second bit will be different for every query. Like it would be rerun for every query. And therefore, I need to see where I can go and start with somewhere, but also the goal to keep the complexity, like the multiplier, which is dependent on the number of airports, like to keep it linear, that multiplier, I need to keep track of what I visited, and I can query the visited in constant time, which is good. And I make sure that I am not visiting anything more than once. Therefore, like I can be sure that it's linear on the number of airports, but also linear on the number of connections, and it multiplies.
But the connected unordered map, you don't touch it. You don't modify it. It's what
No, I
was,
don't.
It's what I was hinting that you could modify some of the values to say the sets. You could modify some of the sets, saying I can't go back to that airport.
Yeah, I guess that's possible. But as I explained, like following on the John's suggestion, I have one data structure for initialization and another data structure for lookup. So even if it's not obvious in the solution, and that's why it made me not the best representation, but that's the mindset I had. One is for lookup. Sorry?
This presentation to disconnect the loading of the direct flights from the querying.
Yes.
Does it
like I could put it in a class as first I could put the direct routes into the just constructor of the class, for example, and then query if route exists by only passing the query.
The way you did it, it's by is it easier to test, to say, okay, this bit from at the start, I'm not going to modify it, and then the rest is. I'm just trying to see the logic in terms of testing the design.
I'd suggest to catch up on this after the class.
Okay, sure. Okay.
Any other questions so far? Let's keep going then. So now to the material of today's class, and we're gonna start with STD map, and that's our problem today. I don't have any algorithmic problems as I had in the previous times, and we just we have much more basic problem. We're just trying to compile this, and the idea here is that I have a user ID map. And instead of using integers for my user IDs, or like longs as I actually declared here, I decided to wrap it into a type. I find it quite practical in projects which are longer than a couple of functions, because if you have two maps in the class and both of them have the same keys, but they actually store different things, it's very easy to misuse a map and query a wrong thing. And here I can clearly read that it's a user ID map, which is nice. But the inconvenience that this is not going to compile. And it's also going to give us very cryptic compilation error. You can try it for yourself. I didn't try to reproduce compilation errors because various compilers are going to give you different message, but all of those which I've seen are pretty horrible. And I'm not gonna dwell much on the problem, and we'll start looking into solutions. So first, I wanna just before we discuss what's needed to solve it, I wanted to quickly remind what's the map in the standard library, and its underlying data structure is balanced binary search tree. And this kind of helps to understand what's missing from our original type with user ID, and what do we need to provide to use this as a key. And basically, the binary search tree works the way that all the elements on the left-hand side are smaller than the root, and all the elements on the right-hand side compare greater than the root. And this is true for each subtree, and therefore our type needs to have less or greater comparison operator. And basically having just less is enough, because if it's not less, then it's either greater or equal. And if you swap the elements, you can figure out if they compare greater, and if neither is true, then it's probably the same element and it's equal. And therefore it enables the map library type has very minimal requirement. And basically that's what we need to do to make this compile. That's the same user ID type we had before, but I overloaded operatorless for this type, and that's typical syntax of in-class overloading of operator. I take another value which we compare with, and I just return. I just compare the internals of the type, and it's very easy to provide some ordering for the values. It doesn't actually make difference how do I compare, and I'm going to talk about it later. I just need to come up with some ordering of the values of the type. Therefore, when they are put in the map knows does it go to the left or does it go to the right. And I also did some checking, so it's kind of my user ID type behaves as I expect, and you can see that 1 is less than 2, 2 is not less than 1, and 1 is not less than 1. Exactly what we expected from our comparison operator. Another thing to point out is that it needs to be const, otherwise you get horrible compilation error. And just first thing I usually double check by getting such an error is that did I forget to const the thing, and often the answer is yes. And the rest is the same test which we had before, and this is working, and this is great. Questions so far?
Did you not need to overload all of the operators?
No. Map has a lean implementation, I would say, and therefore operator-less is enough.
Oh,
If you
okay.
just take this piece of code and compile, it works. If you take away the operator-less, it doesn't work.
Yeah, I just tried it and did compile. Yeah, I was just wondering about all the other operators. Yeah.
Yeah, cool. Like only one is enough, and therefore, if you end up in a situation when you need to use a type and it doesn't fit into a map, you need only one piece. Therefore, your job is not that terrible and not that large.
Okay, thank you. Yeah, cool.
I also wanted to first there is another way to do to provide like this comparison function to the map. We can avoid touching the class. So imagine that the type doesn't have the our operator-less, and we can declare a separate type, a struct in this case, because it's short, and Tristan doesn't like to type public in each class when things when instruct things are already public, and this class also can be called a functor. And notice here it's operator parentheses, it's not operator-less. So then this thing itself is invocable. It takes 2 arguments in this case. It needs to compare 2 elements and tell if one is less than the other. I have an invocation example. So if I declare such struct, then created an object of this struct, and then I can invoke this this object. I can invoke an object. Sounds weird, but actually it works. The syntax key is also valid, and yeah, it returns true if because 1 is less than 2, and works the same way here. And the trick is that I can provide the type, not the object, to the map, and the map will instantiate the object by itself and use it for the comparison. So even if my user ID doesn't have the operator-less defined, that's another way how I can provide the way to compare objects to the map, and then the same code works. And I'll probably follow with another example immediately, and then we'll suggest to ask questions. This comparison, as I said, it can be anything. I can implement a different functor, which orders the elements in a different way, and still, in order to make stuff fit the slide, I just decided to use sets instead of maps, and I've put 2 elements in one set, which is ordered by less comparison, and another set which is ordered by comparison of greater than. And I've put the elements, declared them in the same order, but then when you can see both elements are there, but the one starts with 1 and another one starts with 2, which means that they were ordered, like the second one was ordered the other way because I changed the way I order the elements. And here I'm going to ask for questions.
I guess there's a convention not to be confusing.
Yes, this is a great convention, but also sometimes you, just for benefit, you may, with more complex types, for example, you wanna sometimes order by, I don't know, the size of the vector, and sometimes by the other properties of the vector or properties by arbitrary type. And therefore, this one is confusing, but I wanted to show you opportunity, and it's basically, and say you use it wisely. And sometimes it actually makes a good case here. This is not a good case. You always can grab the elements from the back of the container rather than just reordering by a confusing comparison functor.
Mm-hmm.
Any other questions?
But your comparison functor, how different is it from Lambda?
I think you can provide Lambda, but I always had like confusion with how to feed it into map. And basically, the trick is that you need to declare Lambda in place. Then you need to figure out its type and then provide it to map. And it's kind of struggle. And it's much easier to just declare a type, because the problem is that to the map or to the set, you are providing a type rather than the object itself. And the Lambdas are usually easy to pass as an object, but dealing with Lambda types is discouraged because you cannot ever predict them. Reusing Lambdas, for example, is rather tricky, especially in different places. And reusing this comparator is quite easy because it's a type.
Oh, yeah, okay.
Let's go more serious. And now, like, we're going to talk about, I called this composite key types, encouraged by some databases. And composite key is when you don't have one single thing you can compare by, and you need to implement a trickier comparison. I made up an example. I'm not a football expert, but I thought it kind of may help to just understand that when one element is not enough. And I decided, I decided to try to understand how do I identify a football player. And they have their numbers, but like on their jerseys, but in different teams, people may have the same number. Therefore, basically, team and a number may be a thing. But apparently, if one player retires and another one comes in, they may take the number from the previous year. Therefore, it looks like if we are talking by the year, the team name, and the player number, this should be a unique identifier of a person, of a player. And that's how I came up with the player ID. If there are any football experts on the stream, please correct me. And anyway, we will have run with the example that I've got, but at least for the future, I will know how wrong I was. Then I create a map from player ID to player name, which I represent by string. And for example, in the year of which started in the kind of competition year which started in 2019, number 14 of Liverpool was Jordan Henderson. And for Tottenham, number 1 was Hugo Lloris. And that's how I can encode things into a map. And the tricky thing about it, that this example does not compile, and you know why. It doesn't know. The compiler has no idea how to compare one player ID to another, and therefore, when we need to put these players into our beautiful binary search tree, there is no way to figure it out. And in the next slide, I'm gonna show you how to do it. So far, are there any questions if the problem is clear? I'm going to move on, and we'll suggest you first like a very ugly comparison operator. I will show an improvement, but this probably helps to illustrate basically what we are doing. And we don't care, like, for example, with values, it was pretty straightforward. 1 is smaller than 2, and we can then we can run with it. it's also it's like natural ordering. Here, I'm not sure what's like lesser than and what's greater than, and we don't care about it. We just need to create an order, and such order that if we pick any possible values, they will be clearly ordered. And the way I approached it is like I took all the fields which can have different values, and for example, if I only take into account years, obviously, like there can be more than one player in the same year. Same goes with the team, and as we discussed, player numbers also can have collisions, and therefore, if the year is different, I can start ordering by the year. Then, if it's not different, I can order by something else. The order doesn't matter. Team is listed the second in the type definition, but I can start with the player number when I'm ordering because I can, and it's not that important. And maybe from the point of efficiency, comparing integers will be faster than diving into strings. But again, first measure your performance if it's critical for your decision making. And if the player numbers are different, then we can order by the player numbers. And if they're still the same, we hope that the teams are different. But it doesn't matter basically. If they're equal, then it's a fair result, a fair outcome for the operates less. And nice thing about modern C++ that there is a way to shorten it. It's more of like a trick. It's not an obvious one. I wouldn't come up with it myself. I just saw it in someone else's code, and it makes sense. It's logical. It works. Does exactly what I want, and also writes much more concise. And there is the standard function called stdtie, which returns a tuple. A tuple is like a pair, but with not only two elements, but more elements. So they can be of the different type. And actually, it's a tuple of references. And the nice property of a tuple is that it has lexicographical comparison defined for it. It goes basically element by element. And if they are different, it can deduce the comparison. If they're equal, it jumps to the next element and goes further. And that's the way we go. This code does basically the same as the previous example, but it's much neater, looks much neater, and also less error prone. The less code you write, the better you are. Like I've written a few errors in examples like this, and I've seen a few errors. And with stdtie, there is less opportunity for error. And also you can, for example, wrap it into a Lambda and just apply the Lambda to the type itself, and it's going to be even much easier. Any questions here?
I know this is a sort of a demonstration, but would you put player ID in as the tuple?
What do you mean by player ID?
Well, the struct. Could you not define that as a tuple?
Usually I don't want to because it's tuple will put a lot of stuff in front of you, and you don't maybe need a player ID just in itself. Also, if you define it as a tuple via using, if you have a tuple with a similar underlying type, they're still going to compare, like they will be basically the identical type and interchangeable. And I intentionally want player ID to be custom type in this case.
Okay.
And maybe this thing has other properties and so on. And like I don't gain much by having it as a tuple.
Yeah, okay. More flexibility.
And Tristan is pointing out that in C++20, compiler will automatically generate comparisons for you. And yes, it's the last C++ standard which we have to deal with these terrible things. And the future is much brighter, but because we're not in the future yet. And also in C++, you have to deal with the past for quite a while. I think it was worth telling you this, but also it's worth telling that there is hope, and language is going to do more for us and be much more concise and practical.
Okay, thank you.
And these are the basics which we need to know about the map. We only need to define less than comparison, nothing else. Good question, John. Is just like, that's the only piece of work you need to do. I showed you two ways. One is overloading the operator less. Another one is you can create a custom functor and specify it as the parameter of the map type or the set type. And STD tie comes handy when you have multiple members which you need to put into comparison. I'd also like to point out that you don't need to put all the members. You only need to put those which make each value distinct. If you have some like cache or something, you don't need to store it there and so on. You only need to put those which allow you to distinguish between different actual values. And yeah, you can tweak the order of elements in your container by the way you implement the comparison operator. And that's all I wanted to tell you about the map. And now it's your time to shine. It's practice time. And I would like the practice today is going to be to implement similar thing by yourself. It's not that tricky. I just created a very simple date type, which has year, month, and day. And have a few examples here how I use it. I have a map which classes of my course happened on which date, and if I put two dates in the map, then I can like there are actually two classes in the map, and then I can look up that I can find both dates. I'd suggest you, like I suggest we have a break for about 10 minutes to do this quickly, and let's get back to the lesson at, I say, 7:30 London time.
Okay.
I'm going to be away for a few minutes. We'll have a little stretch, and then we'll be happy to ask questions. And if somebody wants to show their solution, you will be welcome. I'm back with you. We still have like 7 minutes to go for the practice. John shared a good solution, and I wonder how everyone else is going with the exercise.
Yeah, a subtle hint you can look on one of the previous slides. Hey?
Do you want to share yours, John? As like, I think we have 3-4 minutes to go.
I've sent you it on.
Yeah, just like mine is going to be rather similar, but I can suggest you share the screen and just talk it through.
As basically, it was it's very similar to your one on the previous slide. We're using the tie and just the order with the other year, other month, and other day.
Like this?
Yes, yes. So you just insert the bool operator less than. I guess you could have done it with a functor as well, could you?
Yeah. But in general, like I think if you don't have a reason to go with the functor, it's just like this one is more concise.
Okay. Let's try it. Yeah, it doesn't seem to like the functor one. I'd have to go through it a little bit more detail.
You might prefer the functors, for example, when there is something special about how you, like when your class already has the operator less, which makes sense for the class. As I don't know, you have like money type or just some interesting number type or something. And you don't want to confuse your operator less, and you still need a different ordering in your container. In this case,
Okay. So yeah, it's more. You can do more custom, basically.
Yeah.
Yeah.
But if you don't care how do you actually, like, if you don't actually care about the order for the type, or it doesn't make sense. Like here, actually, for the date, the ordering is pretty natural, and these operator less can be reused for other purposes, just for comparing dates. And you don't need to reinvent anything else.
Yeah, it makes sense, doesn't it?
We'll still wait for 2 minutes for other people to gather. Meanwhile, I'm already spoiling the solution.
It's interesting. I've never seen that STD tie before. That was really interesting.
Another place where it's useful, just kind of digress a bit, is when you have something which returns a tuple, or I guess also works with pair, and you just want to assign it to separate variables. And you can say std tie equals, for example, function invocation and function return the tuple, or just std tie of separate variables equals just a tuple if you want to assign a tuple. This is like very handy syntax.
Yeah, that's good. I don't think I've ever had. I've not in my stuff. I've never actually done a tuple before, so it's quite.
There are some cases where tuple is useful, but especially some people use it when you need to return more than one thing out of a function. But I would encourage in this case, instead of a tuple, use like declare a simple struct and give the struct a meaningful name, and also then you can give the members, the struct members, also meaningful name, and it takes you what 2-3 lines, but revising this code from the point of readability is much easier and much better.
That's good. It's good. That's like,
It seems in Python, tuple is more prominent.
Yeah, tuple is like a fixed length list in Python and in C++. I don't know, lists and vectors are usually containers, and there are arrays for this purpose. Although in Python, lists and tuples, they can contain different objects of different types, and C++ is less flexible on that side, strict on types. For those who were just coming back after the break, I shared the solution for the exercise, and here we just need to declare operator less with the same trick with std tie as we used before, and this makes the example compile and work exactly as we expected. And not only this test, but all the properties which we would be expecting from the map. Any questions on the exercise? Then I'm gonna move further, and we're gonna do exactly the same thing for an audit mob. It's going to be slightly more difficult, but still, like, we already know the basics, and like we already know the structure and the expectation, and I think we're going to be able to crack on it. So we start with the same thing, and also I need to thank Tom for assisting me in this exercise by just being present as another user. And I needed to come up with some name, and Tom was chosen. Thank you, Tom. So yeah, in this case, this is not going to compile again because something is missing, and in the next 30-40 minutes, we're going to discuss what exactly is missing and how we provide it to the compiler so it's happy and makes everything work and so on. I'm going to remind, like, this is a reminding slide from the previous lesson about the underlying data structure for unordered maps and unordered sets. It is a hash table, which is organized in such a way that it splits into buckets, and the number of buckets is kind of dependent on the number of elements in the table. And in ideal situation, there is not more than one element in a bucket, but also there are not too many spare buckets. And the way an element is attributed to a bucket is by computing a hashing function, and hash function is mapping from the type to unsigned integer, which is going to be a bucket number, somehow transformed into a bucket number. Actually, it just needs to be unsigned integer, and the expectation is that for two distinct values, it's better be two distinct unsigned integers. In this case, they're likely to be attributed to different buckets. And also when we have a collision in our hash table and two elements end up with the same bucket number, we will have to use equality comparison so that we don't kill one element which actually just like got unlucky to have the same hash function value, but is actually a different one. So instead of one property, which is less than comparison, here we need to have two properties, and there is no way to overcome it because we still need to be able to exactly distinguish the elements. And we're going to use equality comparison here. It's shorter than comparing less in two directions usually, because it's just like one operation instead of two operations. Plus, sometimes it's much easier to implement equality to tell things are equal or not equal rather than figure out their ordering. But also the requirement of the data structure is to have a hashing function, so it's not like it's unavoidable to have both things. And after explaining this, that's basically the way for the simple case of just user ID with a single value inside of it, how we're going to do it. Let's start with simple things. The equality comparison is done with overloading of operator equals equals. And the rest of this operator is the same as operator less, but we are comparing for equality here, and we are comparing for equality for the content of the type. The tricky thing comes with the hashing function, and how do we supply it to the unordered map? This may look like a weird and unfamiliar syntax, and I would agree it's like the not the most concise and elegant way. Let's just figure out what's happening here. We need to define a template specialization for std hash for our type. I don't expect you to know what's template specialization, and like we'll soon figure out what std hash is. In the end, it's just like a syntax, and the same approach with just copying and pasting, as like John called out recently, gonna go well here. And like what we need to do, there is a std hash which is defined for all the basic types. I can show it on this line. Like for example, we're using it for unsigned long, and then in order to put a custom type into our unordered map, we need to provide the specialization of this std hash for our own type. And the way we do it is first we need to put it into namespace std. It's not encouraged to put things, any like random things to namespace std for your convenience or something, because it can cause name collision. But here our particular goal is just like to work with our custom type and just define the specialization just for our type. And because it's a template which is specified for multiple types, and I think there are going to be more details on templates in further courses. For now, it's just like weird bit of syntax. Template is a generic type which can provide consume other types as parameters. Basically, as we discussed, vectors and other containers are also templates in this case, and you can specify vector of what or an audit map of what, and what's the value type. And in same way, hash is a template, and it's also a functor, something what's invocable and has operator parentheses, which returns size t, or you can say unsigned integer. And the input parameter is the object of our type. And in the case of user ID, because we have one value, it's pretty straightforward that hash of this value is going to be good hash representation of our type. We wrap one into another, and we're done. And now it's time for your questions. The silence is suspicious. I'm surprised that everything is clear here. But if that's the case, let's move on. And I wanted to show similar thing as with functors for the map. We don't need to like specify type properties. We can specify separate functor types and provide them as a parameter for our unordered map. And in this case, I specified at least they don't need to go to they don't need to go into STD namespace and so on. They're fine. For example, the hash functor is just fine on its own, and inside it needs to have operator, the same operator parentheses, and you need not to forget to make it const, and it does the same thing as I did before. And operator equal actually can be also replaced with a functor, same operator parenthesis. In this case, it's Boolean, is it equal or not? And takes two things and needs to say, is it equal or not? And then we provide these types as parameters for our unordered map, and it's going to work exactly the same. There is a question from Vlad on YouTube that std hash has its own hash function, and we don't need to know it. That's correct, because we rely that it's a like good and efficient hashing function which provides like good distribution for us. And instead of like inventing our own, we just take advantage of something what has been already like thought of and tested and proven and discussed and so on. Therefore, we just like for the types where there is a hash function implementation, we just take advantage of what has been done. And when we need to create something our own, we compose it from the pieces which are provided in the library. It doesn't need to be standard hash. There are some other hash functions, but I'd remind that those hash functions need to be efficient to compute and also provide good distribution. And that's what has been done, I guess, for std function. Is just like it's. I didn't even look into it. I'll talk about some other hash function, but about this one, I didn't even look into it. I just expect it to work. Haven't heard anyone in particular like complaining about that one. And it's considered a good practice just to use library functions because they are well tested in this case, unless known or otherwise. Any questions here?
Yeah, I'm a bit confused on the return on the operator size t.
Okay.
You're returning the stat, or maybe it's not. I'm familiar with the std hash thing, but you've got std hash, and obviously you've got your type. Then in the curly brackets, there's nothing there, and then in the curved brackets you've got id.value. Obviously, you're taking your id as a reference to the value in your struct. But I looking at that, I would have thought the return would be a bool, because you're taking, what are you actually returning from your STD hash there?
So I probably, like the previous slide, might be helpful, as std hash is a struct which has operator parentheses overloaded, which means then when I create the object of this class, it's invocable. But in this example, or even actually even in the first example, first I need to create an object of std hash, and that's what I do with the curly braces. Normal, like circle parentheses also go here. It doesn't matter, like the outcome is equivalent. It's just like stylistic choice. And then as I created the object, I invoke this object with the parameter of ID value, and the object of this std hash type should return size t. That's like, as I said, our hashing function is mapping a value of the type into unsigned integer. So we need to return unsigned integer. Boolean only says yes or no, but in our case, if I go another slide back, we need to attribute the element to one of the buckets. And for example, what would imaginary hash map implementation do is take the integer from range of 0 to 4 billion, divide it by the number of buckets, and just take the remainder of the division. And that's the number of buckets. That's the number of the bucket which element goes into. There are some other tricks which just will help you with collision avoidance, but this is like the rough idea how it may be implemented. So you need to return a number for each value of your type, and that's why it needs to return size t. Could have been like unsigned long, I guess, but dependent on the implementation. In the standard library, it's size t. Did it help?
Yeah, I got that bit. So, and then, but I'm just looking at the. Okay, right. So it's picking up. It's returning the hash bucket. I'm just looking at the test now. It's returning the hash bucket when you call the user ID check.
Where do I look? Sorry.
I'm just going through one of the tests, say, for the check.
In the further slides, I guess.
No, just at the bottom. Say the check usernames at user ID 1 equals Alex.
It's not like it does this like hash bucket computation again internally. It doesn't immediately, like your std hash implementation doesn't need to return the hash bucket, and don't try to guess the number of buckets in the hash map at each moment. It's a number which is going to be transformed into the bucket number. And here by the find or at is the syntax which allows us to access an element which is there. Otherwise it throws, and I'm basically, this shows me that I can query my name in this case by the user ID 1. And that's exactly what I expected. If I insert it as by the user ID, then I can get it by the user ID 1.
Okay. So,
and I will have more examples of the hashing in the further slides, so it also may help.
Okay.
And here we come. I wanted to show what happens with using very poor hash operator and poor hash implementation, poor hash function. And that's like the poorest hash function you can invent. It always returns the same value. And my expectation was that like if I use the same value, the element's going to be attributed to the same bucket. So this test has this test also has an illustration. How do I actually check which bucket the element went to? You don't need to use it in real life. I just wanted to have some kind of testing illustration, and basically the fact that you can access it is good for education purposes, but it's like you usually don't use it in day-to-day code. And because the things are not guaranteed about good hash functions, like they are not exactly guaranteed. Things are likely, things are probable, but not guaranteed. Therefore, I just decided to run with more than one user ID and see how it goes. To make the example shorter, I just went with sets, and I already had my hash on the previous slide, which just was returning hash of the value. And I create one set with good hasher, and I call it well hashed. Another set with poor hasher, and I call it poorly hashed. I put the same values there from this vector 1, 2, 3, 4, and because my equality operator is correct and nice, both sets contain the same number of elements. So they all landed there well. Yeah, and then what I'm checking here is that I use all of its algorithm, which has taken that some predicate, in this case, predicate which is a function which tells yes or no. It's a function which returns Boolean. And so I'm checking that for each element of the container, the predicate is true. In this case, all of is going to be true. For the poorly hashed set, all of the elements are ending up in the same bucket, and I can check that for the well-hashed set, not all of the elements are ending up in the same bucket. There are at least some elements with different buckets. The bucket attribution is going to be different and implementation dependent, but at least I had my hope that like with well-hashed set with a good hashing function, elements will be attributed, and my hopes were fulfilled. And I think for the poorly hashed, it's pretty much guaranteed that if you return the same value, elements go into the same bucket. Any questions here? Then the next I'm going to talk about the same example with play ID, when we have more than one value to be incorporated into our comparison and into our hash. And I'll particularly focus on the subject of combining hashes, because that's what's tricky, and you kind of you need to be more inventive with your hash functions here. Welcome back to our example with the player ID. I omitted the type definition here, but just show you an example. And as you may remember, this should not compile, and if you try it, it won't. Before we define, as for the simpler type, the equality, like the equal comparison operator, and the hash function. And this is probably the largest number of line I tried to put into this slide, because it all goes a bit ugly with defining the std hash for my type. But now we need to speak through it. Let's start with simple things. Operator equals is going exactly the same as in previous cases. We just use std tie and compare the things. And Now we're going to have fun with std hash. It's a quite wide problem. How do you make a hash function of multiple elements? And one of the simplest things, which also considered like as a best practice, and in general, unless you doing something, unless you have either significant security concerns or you have reasons to believe that there is something special about your types which may cause hash collisions here, this case is likely to work with very simple hash combine function. And the idea that when I take two elements, if I need to figure out how to combine two hashes together so that they don't negate each other and turn into zero, and therefore various values may end up into the same buckets. And first I'm going to talk about the thing I'm doing here. I defined the function hash combine, which I use for multiple elements, and I start with 0 and then feed this hash as a seed parameter, and then do the hash calculation here, and reuse this function multiple times, and that's how I accumulate. I can say accumulate the hash, yes. And I'm gonna just give a quick reminder what this like magic arrows are in the hash combine function. These are bitwise operations, and one is bitwise shift, another one is bitwise XOR, which is like Boolean algebra on bit by bit values. Starting with the shift, 0b is one way to write a value in binary notation. So it's 32 bits unsigned integer, which has all ones. It's the largest possible unsigned integer. And the first two lines just illustrate what happens if you shift it left with two arrows and parameter 2. Like if you shift it left by 2 bits, like all the bits go to the left, and the new ones just filled with 0. So you can shift it right by 5, and in this case, like we add zeros from the left, and if you the maximum you can shift is 31. After this compiler starts warning you that you're kind of zeroing your value, and you can see that it's all filled by zeros. And not to get confused with ones, I just pick a random value, and the next example, I kept it round to 8 and 4. Therefore, you can see the patterns as, for example, when I shift right by 8, this octet of elements just jumps here, and the next one goes one right, and the next one goes right, and the next one just disappears. And from the left-hand side, we fill with zeros. And you can double check that the same applies when we shift left with 4. We add 4 zeros here, and the rest is just like shifted, but the bit values are the same as they were. And brief reminder of Boolean XOR, which is exclusive OR, stands for exclusive OR, and it's just like a Boolean function, which is easy to discuss as 0 XOR 0 is 0, different values give 1, and 1 XOR 1 is also 0. So same values get turn into 0, and different values turn into 1. And combination, like you can see that it's bitwise, and you can do bit by bit comparison. U at the tail is just makes it unsigned. It's not very important for this purpose. It's just like makes compiler a bit happier. And interesting property of this operator, if you do XOR with the value itself, it turns into 0. And you may see this trick in as an assembly optimization. If you go and look up what assembly is produced by your compiler, it usually prefers, when you need to zero something, it prefers to do XOR on it because it's more efficient than writing 0 into it. just a random fact which might be interesting. And then getting back to our example, that's what we are doing. We try to shift, so we shift the previous hash value by 1 and combine it with the existing hash. Shifting is important because if, for example, I had a year and a player number being the same, unlikely in case of the player ID, but in other types, if they are the same, therefore their hash is going to be the same, and therefore they're going to zero each other out, and that's not very good. That's why, and shifting helps to avoid this. And unless you have tricky dependencies between your types, as for example, one is always double of another, and or hash function kind of has a collision that it produces always the double number of another, and it's a frequent case, you're pretty safe with just shifting by 1. And I do also incorporate the hash of std string. So std, this also illustrates that std hash is defined for all the at least for most of the library types you want, and that's the way I have implemented a composite hash of multiple items in my type. I believe there should be questions, so please ask them.
So does the hash increment on each call? Is that what you're?
No, it doesn't. I'm just basically, you see that I take this hash value, and in this case it's seed. Sorry, it was confusing naming, but it's just like a conventional thing that you have an accumulator which is basically passed as a seed. It's like some seed also can be considered as some initial value which is going to affect the current result, and basically we incorporate the seed but shift it and then XOR it with the current hash value. Okay. And it's kind of, it's not exactly incrementing, but the original seed, or at least the derivative of it, with which hash combine implementation, it's going to be drifting and drifting and drifting by 1 bit.
But isn't the seed 0 when you call the?
It's 0 here, but then we assign it. So on the next invocation, the hash is actually the result of hashing the year. And on the next invocation, hash value is going to be a combination of the year shifted XOR the hash of the team.
Oh, okay. All right. Yeah. Okay. So you.
And on the next invocation, it's year shifted twice. XOR team hash shifted once. XOR player number hash not shifted. That's basically what ends up there.
Okay.
And speaking of just some best practices, because we know this simple hash combine, but it's not difficult to craft counterexamples for it, and you may see that it's not going to work everywhere, although it's likely to work in most of the cases. But I just wanted to take an illustration of another hash combine function, which is in the Boost library. And that's what Boost is doing. It's taking the seed, the same seed as we which we used in our simple hash combine, and does shifting to the left and shifting to the right. So like some of the bits go here and there. Also add some arbitrary value. And I've read about this thing, and the property of this thing is just like the correlation. It's some derivative of an irrational number, and there is some magic about it, which you may find in the documentation. And the idea that it's it has uncorrelated bits, and if you can adding up and adding up and adding up, because you combine multiple times, it's gonna more uniformly fill the entire space of the unsigned integer or size t domain. and it also takes the hash value of your thing, and basically when you do it and then XORs it to the seed, and this way it's pretty quickly starts like if you do multiple things with this hash combine, it's going to pretty quickly distribute across a wide range of the values. And this implementation is also well tested. There is some critical analysis to this, so you probably don't want it to be like, you can find some cases where it may not work, but it's less likely, and it has been tested wide, and it just like widely and helps a lot. So if you have a Boost library available to you, you may prefer, instead of implementing your own hash combine or like copy and mine, use the one which is provided in the library. Or if you have other libraries like Qt or Upsale, which are already used in your project, you probably want to take advantage of their hashing functions. First, are there any questions here? Then basically I'm going to conclude with the unordered maps and unordered sets. As we discussed, they require equality comparison hash function to be defined in order to be able to use the key type. The same way as for the STD map, you can provide them as type properties. In this case, it's this scary template specialization for STD hash and just equality operator overload, or you can implement them as a functor. And despite template specialization sounds rather scary, but the copy and paste approach just works. But you need to really pay attention for good performance of your hash map. You need to pay attention how you combine the hashes of multiple member types in your hash function, and therefore, if you have a library like Boost, Upsale, Qt, or some other generic library, take advantage of the hashing mechanisms provided there. It may take a bit of learning, but also you'll probably find some tutorials, or if you Google it, how to use hash combine of particular library, then you'll find it there, and then you just incorporate it, and it works. And the good thing is that you only implement it once, and you don't need to touch it very often. This is it for unordered maps and sets, and now it's your time to shine. We have the same exercise but with the unordered map, and have another 10 minutes break, and we'll come back to 8:15 London time.
Just one quick question. Once you mentioned there's another structure called a flat map. Can you say just one word? I mean, can you remind us? And is it helpful, for example, to solve the airport problem?
Flat map would be like a substitute for all other maps, and the idea of flat map is just the underlying implementation is a sorted vector of pairs for the map in case of the map, and it's also going to be a logarithmic lookup complexity.
Okay.
And its advantage is that if you need to iterate over it very often, it's very efficient because it's a contiguous array. Oh, yeah. But also the thing about flat map, it's not in the standard library, and that's why I'm not talking about it. You can find one in Boost. You can find one in some other generic libraries or just like type collections, but it's not in the standard library, and I think it's not even common in C++ 20. Like, it definitely not common in C++ 20, and the question is, will it make it to 23?
And it's something you use yourself quite often?
No, because like at least in the project where I worked, it wasn't available as a part of the library, and the like iteration performance or memory compactness wasn't a critical thing in our case. It looks like it should be beneficial, for the cases where you don't change your map. For example, you know all the values from the beginning, and it's compact, so therefore it's going to be much more efficient in terms of caching. As soon as you read the first element, the entire structure goes into the memory, and then everything else is just like comes from the cache. Plus, it's really compact there. But again, you should measure before you make like significant changes, and drag in some significant dependencies there would be questionable. And we didn't struggle from the like maps performance of the maps which are available in the standard library.
Okay.
I would also add, I don't know, from the point of clarity, I can imagine people starting complaining that now you have 3 maps in standard library and you need to choose which one is appropriate. And it's questionable choice, like as the default just map becomes a questionable choice in this case. Just some legacy of C++. John shared a solution which looks quite similar to mine, and it's correct. So how is everyone else? We're gonna continue with the material in 3 minutes. Meanwhile, if somebody else wants to share the solution or has any questions. I'm gonna spoil the outcome and share the solution which I have. So people, like, for the last couple of minutes, people can revise what they have and see if they have something similar. You could also do this with functor parameters, or maybe with some other choices. I don't provide my hash combine function, as I already brought it before, but it's basically the same in this case. It looks like it's time to continue. Here is my solution for the problem I presented, and I wonder if there are any questions about the solution. It's basically very similar to what we've done with the play ID, but just a little bit simpler. And cheers to those who try to implement it by yourself and make sure it compiles and so on. Now you have an example how to do it, and if you need to come back to it, you just know where to look it up. And also, like, when there is a discussion on Stack Overflow or something, you got the concept, and you can nail the implementation details. Did someone have a question?
No, I was just thinking, I think one of the things I'm going to do is when you run through it, you can sort of like do a debug or couts and then work out how it actually constructs itself as in step by step. I think that would be a good exercise to do. Yeah,
this may be useful. I'll just warn you that it may be a bit tricky with the binary values, and you may want to look up the formatting properties. So the cout gives you the output in binary, because we're doing all the binary operations here with hash combine, and when you're playing with it, probably a little bit of formatting will help.
Okay, thanks.
Now let's continue with what we've got left. I wanted to say a few words about multimaps and multi-sets. And basically, what's a multi-map? It's a map which allows multiple entries of the same key. As you may remember from the previous lesson, if you insert, like if you do dot insert with the same key, it's going to fail and leave the previous value assigned to the key, or you can do insert or assign, and in this case, it will override the existing thing. And you cannot have multiple values of the same thing, multiple values of the key of the same key in the map. And multi-map is just like more relaxed type, which allows the multiple occurrences. And here I have an illustration. Those who were with me from the beginning remember that I had 2 sessions on my previous date, which was quite a while ago in February. And yeah, that's how I reflected it in my multi-map. I wouldn't be able to put like 2 sessions together in the normal map, and that's why I came up with the multi-map. And I'm using also the same like date type, which we just nailed it, and which we just nailed, and we can now we're able to put it into our containers. And here are some properties. What's interesting, so the size of the container in this case is 3. And another method which we haven't discussed before is dot count, and you can provide the key, and it says how many occurrences of an element are there. For the elements which are not there, it's going to return 0. I probably should have illustrated it, but like just trust me. And this also works with map. Therefore, like it's kind of can be used as a shorthand for checking if element is there, although it's like reads a bit confusingly. And for example, my personal stylistic preference is use find and compare it with end. At least like it reads better. And we're lucky to have dot contains in the next standard, but still it's the future. And as for now, you can use dot count even with regular maps and unordered maps. With multi-map, it kind of becomes more practical. And a few words about dot find. In this case, it's going to return unit testing because it's I'm not sure. I think I know that the order is preserved, like the order of insertion, but I'm not sure which one is returned, and therefore basically, I wouldn't recommend in your code to rely on what's returned by dot find. But on the next slide, we're going to discuss what's the proper way of querying all the values assigned, like basically which values are assigned to the key in the multi-map. And that's also what Loren already mentioned. It's equal range.
Yeah.
And it returns you that magic thing called pair. It returns a pair of iterators. And this is an iterator range, which the first one points at the first element of our range, and the second one points past the last element of our range. It's a very typical convention in the entire standard library. And if there is nothing like, I'm gonna start from the middle. If there was no such an element which we were querying, basically you can say that the distance between the element is going to be 0, and the first one is going to be equal to the second one of which returned. STD distance is like a helper function in standard library, which will iterate from one iterator to another and just see how many iterations is it. So in this case, 2 jumps from the first to second, because we had 2 elements on the 25th of February. And if we query one element, the range, so the distance is going to be from first to second is going to be 1 element, and the iterator is pointing. So dot first is the iterator, and then arrow second is accessing the value of the pair where iterator is pointing. That's why I'm not fond of pairs. That's like dot first, dot second. It's quite confusing to read. But this one, the first is related to our range, and the second is related to an iterator in a range. Quite cryptic to read.
What if you have like 10 of the same date, then you need the 5th one?
You need to iterate one by one, and also the thing is that you can these are not random access iterators, and basically you do plus 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 until you hit the second. Here is the illustration about it. I'm trying to get the values of all the elements, and that's how I do it. I keep querying this 25th where I have more than 1 element. I check that the distance is what I expected, and basically this distance takes linear time. It's actually iterating one by one, just hiding it from us and checking how many are there. And then if I want to extract the values, I do a typical loop. That's my begin, that's my end, until my running iterator equals to the end. I do plus plus. And for example, you can keep counting if you need exactly the 5th. It's like you need to keep counting and say, oh, it's the 5th, I grab it. On the other hand, you're very unlikely to, like, it's very weird data structure when you know that you need the 5th. You, like, when you query them, you'll probably gonna see through all of them and check some other properties rather than just order.
Yeah, I guess you're looking for the key, aren't you, generally?
You're looking for the key, but then you want to know something about your values too.
Yeah.
And that's the way you look through the values. And in this case, what I've done is just like I was inserting them into the set, and then I can compare that the values of my set are exactly this. And because I use the ordered set, it's like pretty straightforward comparison. Although we'll work with an ordered too, like because equal comparison is is implemented.
But if you had chosen to use a map with a value vector, is it more convenient, or if instead of using multimap you had chosen to store the values inside the vector for each date, for each?
It depends, and I would say I had only a few cases where like a multimap was just convenient for like shorter typing and so on, and easier querying. And in general, in most of the cases, you'll probably use a map with a vector as a value rather than a multi-map. And I think always when I see multi-map, it's something special, and I wasn't able to someone wasn't able to express it in more concise syntax.
Oh yeah.
So the fact that it is there, you like doesn't mean that you should use it. But basically, that's my conclusion on this.
Which,
if you need it, it's there for you. And there are other types which are also there. And they multi-map lives in the include map. Multi-set lives in. Sorry, here is a typo. STD multi-set, obviously. Multi-set is in include set, and the unordered cousins are also in the unordered includes.
And the multimap, you said, does it exist in Java and C#, for example?
I'm not exactly sure, but I will believe in at least in some extended collection, it will exist. Okay. Like I know that in some languages there is like kind of the basic library and then some extended collections library, and it should be there, maybe under a different name, but it's quite typical data structure. Although from the point of best practices, not the most common one.
But you think it's not more? It's not only in C++ that it's not really used very often.
It's not even in C++. It's not used often.
Oh yeah, okay.
It was just added there, but not that you. It doesn't mean that you should use it.
But are they thinking to remove it? Do you think they might remove it from the standard?
Very unlikely, because it's impossible to remove anything from C++. Backward compatibility is a high priority of the standards committee.
Okay.
And we are done with the main material. I'm gonna summarize what we've done today. It's like first the encouragement that I hope now you are less scared of using custom types as keys for sets, maps, and their unordered cousins. And like you now know how to fix your compilation errors, know how to extend your types so that they are supported by these containers, and also you know how to do it efficiently, which is very important in terms of unordered containers. And now also just you need to remember that the things which are required are dictated by the underlying implementation, and you don't need to add anything extra. As I said, please take care of like good hashing functions and making sure that they are reliable. And if you have those available in other libraries, like you might take some helpers from there. That's it about this lesson. And now I'll just go to the home exercise if there are no additional questions. We have a question.
Sorry, do you have a reference for the selection of a good hashing function at all? Is that? Was there a CPP conf talk or something like that on?
The good practice goes as like use what's available in standard library. When you need to combine, I provided you the one which I think I picked from TOE of C++, as just like that's good enough.
Okay.
And I say I used Boost for illustration as it's still like from the point of computational efficiency, it's very close to what I showed. It's just like 3 simple arithmetic operations, and they're pretty like reliable in terms of even distribution. And like the best practice goes, what's available in the library. It's better to use what's in the library rather than to invent something by yourself.
Okay, sure.
Because the thing is that even when I'm making the simplest code, I can make a typo, I can make a bug, and so on. Like at least when I'm coding, and therefore I need to make sure that I also write tests. And if I borrow the function from somewhere else, somebody else already taken care of the test, and if there is something bad, they spotted it.
Cool. Yeah. Thanks.
Vlad has a question about example on the multi-map here. And yeah, the second second iterator is pointing past the element of interest here. So basically, it may like in this case, it's going to be also likely to be end of the map, and because it's just like the last element in our map, and this map is ordered, so you don't want to dereference it. Only when you are iterating, you know that you go when you hit this one, it's the end of your range. And now to the home exercise. First, the next lesson is going to be the last lesson of the course, and I have some ideas what I should run, as like there are some things which I haven't spoken of, but it's just I decided it might be a good idea to suggest you to bring up topics which you might be interested in, and give it a bit of thinking. If I haven't covered in this course which is interesting for you and which is related to standard library containers and algorithms, or some utilities related to the subjects which we've been talking, or if you have questions about uses of particular algorithms, please send them to me. Slack is the preferred channel, and I would provide a submission deadline by this Friday. Therefore, basically, I have some time to think about it and see what makes to like if I have enough time to talk about it. And the idea that if it's important, if you find it's important, there will be some other people who are beginners in C++ and may also find it valuable. And therefore, don't be shy, and please send your questions, and I'll see if I can spend some time on it and make things clear which are useful for you. And also, like now to the home exercise. This one is going to be fun. It's a bit bigger than usual, and also will take more time to set up, and I will give you more freedom and more opportunities to make mistakes. As the last exercise, I think is kind of deserves to be a bit bigger. And we're doing some tricks with palindromes and anagrams through the course. And now it's time for the ultimate anagram exercise. I found an English language dictionary, and I will suggest you to look for I will suggest to look for anagrams in the English dictionary, and we'll query 2 things: the longest anagram in the dictionary, like a pair, or maybe a bigger set of words, which one is anagram of another, like what can be the longest, and what's the length, and also which are these words. And also the set of words, which like is just the biggest set of multiple words which are mutual anagrams to each other. At least, does the phrasing make sense? What do you think? And then I'll go into some details on the implementation.
When you say all the sets of such words, is that all of the words that are anagrams?
Only for the longest anagram. Imagine, for example, you found that the longest anagrams are, I don't know, let's say 42 characters, and then I want to return all the sets of anagrams which are 42 characters, because there might be more than two like separate sets of words which are anagram to each other, but not all the 42 long words are anagrams to each other. Did it make sense?
So what's you get the longest anagram in the dictionary, which should be 42 characters.
Yeah.
And then if there's another one, the 42 characters, then we return that one as well.
Yeah.
Yeah. Okay.
So when it's not one word usually, like it requires at least two words to make an anagram set.
Okay.
And then you may have, like, for example, two sets of two words in this case.
I see. Right. Okay.
And same goes with the biggest set. Like, for example, you, I don't know, like pit and tip are anagrams, and maybe ITP is also somehow in this dictionary. And in this case, you've got the set of size 3. And if it's the biggest set, then you go through all the, like, you try to find all the other sets which are of the size 3 and see, and basically I want to return all the sets of size 3, but I can imagine there are like sets of 4 and 5 and so on, and you just need to see, like, I only care, first tell me what's the number of biggest anagram set, no matter what the length of the word, just like the biggest anagram set. And then when you know the number, give me all the anagram sets of that size, as like having that many words.
Okay, so they have the same anagrams in all the sets. Okay.
I think anagrams are different in different sets, but in a single set, all the words will be anagrams to each other. I'm quite open, like if in the next lesson we will go through the solution, but first I want to give a try for yourself, and I will be just taking solutions, although I should probably limit the number of iterations, like if you want to send me something.
Sure. No, and there's the anagrams in the whole dictionary, basically. Yeah.
You look for anagrams in the whole dictionary, but then because there are too many, you want to filter some of them out. So like these are some properties of the dictionary, and basically I would give you the freedom to implement this function read all words, but in order to make sure that you've done, like, we are looking into the same dictionary, there are some properties of this dictionary. There is a word count, and it's like, you know, what's the first word and what's the last word. And yeah, that's
okay, that's the check to go with it. Yeah.
And it's going to be a useful check for you. Just probably borrow it, and like when you are past this, you are doing well. If something is wrong, look into the dictionary, look into your implementation, and like you can figure out multiple ways to read file line by line in C++, and it's kind of outside of the scope of the course, and by the stuff you studied before, I think you will be able to figure it out. And that's a tricky thing, how we're gonna check it, because I decided to make it like just a function, but the question is, what does it return? And in the end, it's the definition of the function. It takes the words, the vector of words, and returns us a struct which is exciting anagrams, and our exciting anagrams are the most anagrams, like the set with many sets of the many words, and our also sets of longest anagrams. And both of them are pretty similar, although have a bit different properties, and you may want to like see what are the properties. This is like a bit relaxed definition, and if you need clarification, please reach out on Slack. Yeah, a word set for sake of easier comparison and using them here and there, just because these are ordered and have lexicographical comparison. These combine better. So it's a set of strings, and then I have a set of the word sets, which needs to be in each struct. And you need to populate this, so the rest is going to work for you. Basically, if you submit your solutions in this way, it's just like it will be easier for me to test. And that's how I can test it. But obviously need to provide. So I grab the exciting anagrams, make sure that what you've returned is not empty, and then I'll just I will expect you can provide, for example, for a quick check, you can provide the what you need to put in this test that it's working, and by a brief look I will be able to tell like are you on the right track or not, and if it's the right thing, I will be able to look into the code. But first, like make sure that what's your anagram count and what's your word length, and then we'll look into the sets you've got. That's how I suggest to approach it. Although it's not going to be a single function here probably, and don't try to fit it in a single function. See how it breaks down for you. Keep it simple though. You don't need to use all the stuff we studied through the course. It's just like we already done some practice and see like if you can reuse some things here. Again, not all the stuff studied in the course is needed, but it's kind of the final exercise, which is just practice some of the algorithmic problem solving things. And when I showed it to my colleague, he said, oh, this also often asked in the interviews. Not both of the things, but it's pretty typical. Apparently, it's pretty typical interview question. And it's just might be interesting for the purpose of practice. Next time you come to an interview, you know how to do it. Questions here? Questions on the exercise? I would be also like if some of you want to just like are okay with sharing your solutions in the next class, because if people provide some better examples than my implementation, and there are many ways to do it, like I would be keen to give the diversity of approaches, and just let me know if like you're okay with sharing or you're not okay with sharing. And in this case, if you want your code to be incorporated, I would say the deadline should be the Saturday before the class, like 2nd of May. So you will have the entire next weekend, and then the week after it. Vladimir is saying that yeah, it will take a while to do it. I'm giving you time, but just and also you don't need to solve everything perfectly, and I will tell you the answers, at least like how I did it, and we'll spend a good chunk of the last lesson going through it and making sure that everything is clear. But if you want to share some of your approaches, and also like I will be happy to provide your interesting ideas in my material. And also there is a comment on YouTube that somebody has missed the beginning, but the stream is gonna stay there. So like you can always revise it, and I will soon put the slides on GitHub, and we'll provide the link to the stream too. And wrapping up, if there are no questions, as I said before, please join Slack. That's the best way to reach us and to ask questions about the exercise or about anything. And that's where I announce like the links to the Zoom meeting and some details about the classes and so on. So in this course, the next one will be the last one, and we're going to wrap up there. And as I said, please also like send your questions there. And now, as we like made a tradition, we're gonna have a small virtual pub on Zoom as things in London should end in pub, even when we are on isolation. Then like it's a virtual pub as the end of the virtual class. Thank you everyone for your time and your questions today, and see you in 2 weeks.
Thank you.